If you're a network engineer, you know the feeling. That constant grind of configuring devices one by one. Well, in this explainer, we're going to break down the fundamentals of network automation and programmability. It's a shift that's going to totally transform how you manage, deploy, and even think about your network.
So here's our game plan. We'll kick things off with the big why. The actual problems that automation is here to solve. Then we'll get into our toolkit, starting with Python. After that, we'll see how to structure our data with things like JSON and YANG, figure out how to talk to devices using APIs, and finally, we'll see how it all clicks together in a real-world workflow.
All right, let's dive right in. First things first, why should we even bother with all this automation stuff? This is all about taking that leap beyond the old-school manual way of doing things.
I think we all know the answer to this one, right? That repetitive cycle of logging into a switch, then another router, then another switch, typing the same commands over and over and over again. It's not just tedious, it's a perfect recipe for mistakes. This is the exact pain point we are here to fix.
And the solution, of course, is network automation. Basically, it's a method where we let software take over all those repetitive tasks. You could think of it like a modern assembly line, but for networks. It's a self-driven process that cuts down or sometimes even gets rid of the need for us to be typing away on the command line.
And the benefits here are just huge. You're not just getting a little more efficient, you are drastically reducing human error. No more fat-fingering a command and taking down a whole network segment. And that, of course, leads directly to lower operating costs and frees you up from those boring daily tasks so you can focus on the big picture, like designing a better network.
Okay, so we're sold on the why. But what about the how? Well, for a whole lot of network engineers today, the weapon of choice, the tool that really unlocks all this potential, is Python. So what is Python really? It's this super popular scripting language, and for good reason. Its syntax is incredibly clean. It almost reads like plain English, which is an absolute game changer if you're not a full-time software developer. And because it's interpreted, you just write your script and boom, you run it. There's no complicated compiling step to worry about. And to get started, you only need to know a few really basic concepts. First up, variables. Just think of them as little labeled boxes where you can store data. In this case, we're making a box called X and putting the number 6 inside it. That's it.
Next, we've got strings, and that's just a fancy programmer word for text. In Python, you can use single quotes or double quotes, it doesn't matter. The program sees hello and hello as the exact same thing. Simple, right?
Now here's where it gets powerful. Python automatically knows the difference between different kinds of data. It knows that 6 is a number and hello is text. These categories, or data types as they're called, are what allow the language to handle all your network information intelligently.
So now that we have our tool, Python, we need to think about the actual information we're going to send with it. See, to automate anything reliably, our commands and data need to have a consistent, predictable structure. We need a blueprint.
And this is the million-dollar question, isn't it? We can't just throw a random text file at a router and hope for the best. We need a standardized format, one that our Python script and the network device can both understand perfectly every single time. From modern networks, the answer is very often JSON. It's a really lightweight format for data that's also, and this is key, super easy for humans to read. And because it's so simple for both people and machines to get, it's basically become the standard for how APIs exchange information.
For a long time, the standard was this thing called XML, but it can be a bit clunky and complicated. JSON is the modern alternative. It's lighter, way more efficient, and just plain easier for programs to process, which is exactly why it's taken over the world of network automation.
Okay, so if JSON is the data itself, then what on earth is YANG? Well, think of YANG as the rulebook. It's the blueprint that defines exactly what a valid configuration is supposed to look like for a specific device. Simply put, YANG is the empty form, and JSON is the data that you write in the blanks.
All right, we've got our Python script ready to go, and our data is perfectly structured in JSON, all following a YANG model. Now for the last piece of the puzzle, how do we actually send these instructions to our network devices?
I absolutely love this analogy because it makes everything just click. An API is like a waiter in a restaurant. You, the customer, have no idea how the kitchen works. And you don't need to. You just give your order, that's the request, to the waiter who takes it to the kitchen. Then the waiter brings your food back. That's the response. The API is just that messenger.
So the more formal definition is this.
An API is just a set of rules that allows different software applications to communicate with each other. Our Python script is one application, the operating system on the router is another. The API is the common language they've agreed to use to talk.
Now in the networking world, one of the heavy-duty established standards for this is called NETCONF. It's a super robust protocol that was designed from the ground up to manage network devices. It was built to use those YANG data models, it sends its data using XML, and it communicates securely over SSH.
But then there's a newer, more web-friendly option called RESTCONF. It's not really a replacement for NETCONF, but more of a lightweight alternative. It uses the exact same powerful YANG models, but it lets you talk to the device using familiar web stuff like HTTPS. And this is the big one. It lets us use that lovely, simple JSON for our data.
And what's so great about RESTCONF is that it maps directly to the kinds of web commands many of us already know. As you can see, a GET request is used to retrieve data, while a POST is used to create something new. This mapping to familiar web standards just makes the whole world of network automation feel so much more approachable.
We have covered a ton of ground here: the problem, the tool, the data formats, and the communication protocols. So now, let's bring it all home and see what a modern automation workflow actually looks like in action.
So, here it is, the whole process step by step. First, it all starts with the YANG model, which acts as our blueprint. Step 2, we format our actual configuration data using clean, simple JSON. Step 3, our Python script reads that data and gets it ready to send. And finally, Step 4, our script uses a RESTCONF API to talk to the device and apply that configuration.
The key thing to remember is this: all of these tools give you the power to finally move beyond those tedious, repetitive tasks and start building scalable, error-free automated solutions. So really, the only question left is, what will you automate first?